Okay, so we are on number 204. It is Sunday, right? Still Sunday? No, it's actually Monday. So let's change this Sunday to a Monday. Okay, we're working on UILISTS and TAUNAME. That's actually still true, so that's good. So I really want to work on some designs for the I want to work on designs for the table, but before I do that, I have to get this code stubbed in, at least. At the very least, I need to get this code stubbed in, right? We can worry about other details later, but we need to get this code stubbed in. So, the first question is, well, where does this code go? Where does it belong, right? So, UILISTS, or TAUNAME probably belongs right after tau depot, right? Because TAUNAME is just a way, TAUNAME is a way to codify tau depot variables. So it makes sense to put it after tau depot. UILISTS. So okay, well, let's do this, right? So let's start to get it ready, right? So TAUNAME right here, and that's going to be 42 now. Okay. Tau. Formal names. These are formal names, just to help us. Tau cell. Right, it's the names of the tau cells, right? I don't know what else is going to go in here, but that's definitely it. And that means we gotta move all this stuff up, right? So we know that in terms of this, right, that this is now 55, right? And so up here, we want to compile up to 55 now. And then we have to figure out, okay, well, where are we inserting the next thing? So the next thing is UILIST, right? We worked pretty hard on figuring out how UILIST needs to be. This core functions, though, needs to be somewhere else. So new, and then let's save this as, UILIST.f. So UILISTS.f._. So this is the function section. And let's this is in the data section. This needs to be moved, right? So we're going to take the UILIST core functions right here, and we're going to throw them over here, right? And then UILISTS actually will probably need some type of initializer, I think. Because how are we going to initialize the user interface, right? Well, we're going to initialize the user interface by running UILIST, right? So, UILIST for simple right, so UILIST is for dead simple user interface buttons, right? Include ./UILIST.boilerplate._. So if it's not a commonly used file type, then we give it a longer name. So boilerplate, because boilerplate is, I'm gonna shove the boilerplate into its own file more often. So let's do nssbp paste. I don't actually know what that means, but it's drilled into my memory that this is what I need. So over here, right, we're gonna create the boilerplate for UILIST. So UILISTS, right, UILIST halt. That needs to be lowercase though. Okay, so UILISTS, right, and UILISTS here. UILISTS, UILISTS is capital. And right here, there is none. There's not an init none function, right? So what we're going to do here is we're going to define so we're going to find AAC 2020 UI list init nuns as does not exist. Not exists. Right? So yeah, the NE is for not exist, UI list init none, right? And we're going to make the definition of this macro like this, so that if we try to call this somewhere, it's going to blow up in our face, right? We're going to do that intentionally. Okay, so we're going to save this as UILISTS dot boilerplate dot actually dot f dot boilerplate. My bad. Because it's an extracted file from the main function file. So we're pretending it's in the main function file. Therefore, we got to do f dot boilerplate. My bad. So UILISTS dot f dot boilerplate. Okay. So that's good there. But we also need to go into the silence system and stub that in there, right? So UILISTS, where is that going relatively? UILISTS, actually I don't know where that's going yet. So the UI fragment shaders is going to need access to that list, right? These are the UI recs, right? Now the tau fragment shader is I don't know. The tau fragment shader may or may not need access to this stuff, depending on how we want to figure that out, right? So the UI lists. Well, maybe tau frag is just for the tau. Maybe this is kind of very low level, and this is UI lists is kind of an abstraction that's being built on top of tau, is it not? Right? And I think that's the case. So I'm thinking maybe here's UI frags. It would also be easier to make sense of if UI list was directly over UI frags, right? I'm going to go with that. I'm going to say, I don't know if this is the best choice, but that's going to be my justification, right? So we're going to take all this stuff here, right? And we're going to say UI lists. This is our new 53, right? And the UI fragment shaders still has all the information it needs, but the tau frag just can't use these variables, right? So we need like one. That's fine, because UI lists can use the tau frag to, yeah, and that reflects the way we're doing it. That reflects the way we're doing it over here. Okay, that's fine. So let's save this because we just cut out the code, right, and put it in here, right? Yeah. And so UI list core functions. And now this is 53, so this is 54, 55, and 56. So that means that this needs to be up to 56 now. Okay. We're not going to worry about these. These are kind of long-term things that are just here because I know it's eventually something I want. Okay. So, figure out implementation, usage too complex. I don't know. Let's not worry about that. Maybe we're digging ourselves into a hole, maybe we're not. So this is kind of where we want stuff. And we also need to init, right? So UI list hold on. UI lists, right? They're lists. There's multiple user interface lists. Okay. So this is we have the initialization as well. So the initialization code will go here. And we don't know exactly what we need yet, right? We know we need something. So we're gonna do like how do we do the initializers, right? The initializers usually have like a U32, right? So like U32, AAC 2020, UI lists init, and it's going to take a U32 called U32, and then from there we're gonna oops, and then from there we're going to figure this stuff out. Now, do I actually write my braces this way? I can't even remember how I write. Oh, you know what it is? It's that usually I write everything kind of like this. So, let's line up our braces. I think that, should our braces be lined? Should they not be? I don't know. But this makes it easier to cut this, right? It makes it easier to cut and paste this if it's like this, right? Because then we can just cut, paste, right? So, let's put a void there. Put a void here for now. Yeah, so this initialization function, AAC 2020 to-do man vital, and finish this thing, right? We gotta finish it eventually. And this is where we right. This code here initializes all of the different user interfaces for all of the different as so the user interface, I guess, is going to have to know about things in the future, right? Because all the user interfaces are going to be initialized here, right? And we don't want to have to just tack it onto the end and always remember to keep it at the end. We want just it to, we could, but I would rather not do it that way because that wrecks our, that'll completely wreck our build up and layer things on it as we go approach that we're trying to go towards, right? We're trying to stack new systems near onto the end here as we go. And if this thing has some type of weird constraint where it always must be at the end here for whatever reason, that's gonna screw with us. And then think about if we have a whole, what happens when we get a whole bunch of systems that have that constraint where they need to be near the end, right? And then we can't just paste things onto the end, right? Like like if we want to, it should be, as we're building this, it should kind of be like a, when we build a new system, right, it has no dependencies, right? So it should always be safe to paste a new system directly onto the end, right? And if it's not, then that kind of destroys our layered on approach that we're kind of working towards. So let's try not to do that. Let's do 42. Okay, so we want to do a layered approach, right? So I'm just tagging this and making note of this, and so my whole rant, right? Like, we don't want to require this UI list system to always be at the end, because then that just makes it too hard to layer on new systems as we go, right? It should always be safe to paste a new... It should always be safe to create a new system and just tack it on to the end of the library chain, and everything will be okay, right? We want this kind of layered on approach. So we don't want to destroy that, so it does make it kind of weird that this has some from future information, but I think that's the best way to go. So layer approach, let's call this approach layered systems. Let's assume that the current month is good enough to timestamp this with, right? So that we can just put into our notes, right? Well, what do we mean by layered systems, right? The design of this code base is such that when we create a new sub-library, it should always be okay to tack it onto the very end of the libchan. Sometimes this means we have systems that need to know about future systems, which breaks our layered on design, but it is better than requiring that a new certain system always be last. Because if we require a certain system to be last, then we cannot guarantee tacking onto the end of the libchan will always work without fail. TLDR. Always allow tacking to end of libchan for a new system. Okay. So that's kind of what we're talking about. I don't know if it's the best explanation. I kind of question if I don't really have the Feynman touch, right? So basically I don't even understand what I'm doing. Otherwise I'd be able to explain it better. But, you know, so we made this little explanation. So 2:04, and the time is 00:19, and let's just say 23, right? Backdate that to keep with the conspiracies. Okay, yeah. So also we had one more commentary in our code. So let's close this. Well, actually, well, it's good to know that's there. This thing, so from future, what do I mean from future, right? So from future, or actually from future, we don't want to do hashtag from future. So I don't mean that, I mean like at from future, right? Because this would be a specific comment for a very specific case if it's hashtagged, and it's not. It's like a general informational comment, right? So we don't want to use the hashtags, we want to use the at symbols for that. Okay, so from future, let's go look at that. So into here, right, so this is going to be at from future. And what is at from future? What is that all about, right? I really should make an automated script to help me write this kind of stuff. Okay. So this at from future means the sub-library somehow has knowledge of future items in the libchan. This violates our layered on approach. But sometimes a consolidated index of certain things, for example, all editors, future, current, and future, is very useful to working with and understanding the code. And I don't know why I wrote the why I indented like that, but whatever. 204. Time 002222. How about that? Okay. So this UILISTS boilerplate, that looks pretty good. So this thing, that thing. Okay, so now that we know the order, let's close this boilerplate thing. This is good as it is, I believe. Oh, we have to do a no op though. So like, you know, if U32 and then, you know, no op. So we're just going to reserve that for future use if we need it. And then also we have to return something, right? So we got to return 0x, just return something. Let's return 0. And then we want to go into our silence system for a second, and we want to add, based on what we've done here. So, tau name, tau cell names, sure. And this is like it's actually, if we think about it, it's really tau depot cell names, or it's actually tau depot tau cell names, right? Let's say depot tau cell names, right? It's for tau depot, right? Okay, anyways, let's go look in here, right? So, tau depot, where's tau depot? So here's tau depot, so we're going to say, oh, we're going to put U08 tau name right here. Right? And maybe we should start to kind of like, Tau depots, tau cell names. Okay. And so here's tau depot, here's tau type, right? Tau depot and tau type, right? And then also we have UILISTS, which comes after game cam. So here's game cam. And the reason we're going to put this here is because we have the UI fragment shaders, so it might make sense to have it in proximity to UILISTS. Now we can't always do this depending on how we're solving our dependency graph, or how the dependency graph goes together. But we can keep these. We want to keep them in a. We first need to solve the dependency graph properly, but then we have some wiggle room as to exactly how we solve the dependency graph. So the next thing is just to solve it in a way where it makes the most sense. So UILISTS, UIFrag needs UILISTS. So we could put UILISTS here. We could also put it here or like here, right? And that would be okay. But it would, but since we have, but this kind of game cam and edit cam kind of go together, right? And drag com, click com, zoom com, right? These common functions, they kind of should be grouped together in this linear order, right? So we're trying to write, since we're writing our code and we're solving the dependency graph ourselves, we can put some thought into exactly how it needs to be solved. So UILISTS is going to come after game cam, right? So game cam is down here. We have game cam, and then oh crap. So there's game cam and UILISTS, yeah, never mind. U08 UILISTS, right? So UIFrags can have access to UILISTS if it needs it, right? So user interface lists, right? Editor UILISTS for editors. For all, right? So it's the UI list. This is the different user interface lists for all of the editors. In other words, just the UI for all editors, right? So user interface. So UI for all editors, right? It's not just UILISTS is the implementation. The list aspect of this is more of like an implementation detail, but it's basically just the user interface for all the editors, right? We're going to keep the user interface dead simple. Okay, so now that we have that stubbed in there with UILISTS and UIFrags, we can kind of close this, right? Oh, actually, no, we can't just yet, can we? Because, so this thing here, between here and here, and then once again in between here and here, we still have to, so this is the declaration, but this is not the initialization, right? So down here, we have to go duplicate this, and we're going to say UI tau name after tau depot before tau type, right? And this is on. Okay, and then in between here, game cam. After game cam, it's UILISTS, right? And that's also on. So UILISTS and tau name. Excellent. Okay, so now that those are kind of stubbed in, we can look at some more of this code and just get it ready, right? Get it ready to stub this in place. So tau name, I don't think we have a function section for this, so let's just do this and go Control S, save it, and say tau name.f._, right? So no functions. Okay. So in this section, we're just saying, you know, at the moment, now, we always reserve the right to change our mind in the future, but at the moment, TAUNAME is just a file used to help see the forest through the trees in terms of how all of the different tau to tau blocks from tau depot.d are used. In other words, it's a high-level summary file. Therefore, use TAUNAME right? So there's no functions in here, right? It's just a summary file. It's just a file to summarize things, to help us get our bearings, to make the code less spaghetti. Rant 1. Rant 02. This file, to help make the code less spaghetti mentally without over-containerizing the code. Okay. What? Okay, so basically, we're trying to get our code physically flat but mentally nested, right? What do I mean by that? I mean that the code, we don't actually want like a huge nested struct. We want our variables kind of be loose top-level file scope variables, but there is a nested relationship mentally. But when we're trying to find things, we don't want to have to actually dig through data structures that are artificially nesting things just because for the sake of, we don't want to artificially nest things in the code for the sake of self-documentation, right? Things can be mentally nested, but that doesn't mean that they have to be physically nested that way in the code structures, right? So physically flat but mentally nested, right, is kind of what we're going for. So let's go over here for a second and just say, let's formalize this. I want my code to have a physically flat structure in the source, right? This does not, do not self-document. Okay. So, physically flat, mentally nested. And let's change this, right? So, physically flat is technically a generic kind of term here. So, let's fix that. Physically flat. Got it. I'm getting sick of typing. Okay, and then at mentally nested. And then also, let's take this and if we do a hashtag version, right, then you have it wrong. You got it all wrong, right? So at physically flat or at mentally nested, one of those, but you don't actually mean that. Physically flat, mentally nested, and mentally nested is some things are stored just because the code structure is flat does not mean that some concepts have a mental tree associated with them. For example, libchan is documented source code is 100% linear/flat. But it represents a solution to a dependency graph. Right? Just because the mental conception of the code is branching/nested/tree does not mean the code needs to be that way. In fact, making the code 100% reflect our mental models could impose unnecessary structure that makes the code harder to work with, right? So that's the whole idea. (0204). And the time is, what? The time stamp time, not the actual time of day. Okay, so yeah. So let's close this. And then we have this physically flat, mentally nested commentary. We're going to put this over here like this. It's a little @ symbol. Okay, so we got all these rants. There's no functions, C tau depot, right? And then even then, we don't really want to use the tau depot functions directly with this stuff. Okay, but that's good. I mean, we can, it's like that. It's in a big multi-line comment, right? Because this is just commentary. UI lists, right? Include the boilerplate. TAUNAME.f, okay. TAUNAME, okay, so here's where we're taking all these tau systems from Tau Depot, right? And we're giving them kind of like formal names, right? So tau00 is going to be for UIREX, right? Tau14 is UI lists. Tau15 is editor variables. But these are just names. They're not, these names here. So the names on this side are not to be thought of as symbolic constants of this, right? These are the official names, right? And you just have to remember that, oh, tau15 is for editor variables, right? So this is the variable that we want to be throwing around in the code, not this variable. So we're not trying to use this as a symbolic constant where its value could be tau15, and then maybe we decide to change it on a whim and say, oh, it's going to point to tau17, right? We're not using this. We're not using these variables on this side as a flexible manner to to move memory around and to change our data layouts. That's not the intention. The intention of this right here is just a formalization of what these names are, right? We want to, these names are very terse, so we want to kind of self-document what they are, but we don't want to misuse these, right? The only usage is self-documentation. So we never want to directly use these in any function calls. These don't want to be used in function calls. We want to use these directly in function calls, but if we want to check our work and make sure that things are correct, we can before the function call, we can say assert that this is equal to this before we use a function call that takes this, if that all makes sense. Okay, so that's good there. Let's go and get this into our library chain, because we got like, well, before we do that, does this look good? Does this look proper? Yeah, I'm pretty sure this looks good. Let's close this. This UI list thing needs a little bit of cleanup though, right? So we kind of like got our basic ideas, but this UI list initialization section needs certain macros. So we need to define U32 here, and then we need to undefine it, right? So the reason I do my macros like this is because a lot of times if you have like one master macro file where you define all the little shorthand macros that you like to use all the time, eventually that list will do nothing but grow over time, right? So if you have a one master macro list for your whole project and your project is like 10 years old, well, imagine how large it's going to grow, right? And it's never going to be able to get chopped down. It's always going to grow, grow, and grow. So if we keep a macro list here, and then we undefine that macro list here, and we keep it for this function, right? This function is going to be written, and then eventually it's going to be done, and then we're just going to move on, right? So the list here can only get so out of control, but it doesn't create a level of technical debt that will leak into all of our other code. So that is why we're doing it this way. It does make things a little bit bulky, but that's why I glue them to the sections, right? I make these little section headers, and then I glue the, the prologue, and I forgot what the opposite of a prologue is. Prologue and opposite of prologue. What's the opposite of prologue? Opposite of prologue. Opposite of prologue. What is the opposite word of prologue? Epilogue. Epilogue, yes. Prologue and epilogue, yes. So let's go over here for a second. So the opposite of prologue. Opposite of prologue. I don't know how to spell prologue, so we'll just say, like, opposite. We'll make a few shortcuts. Opposite of prologue. And opposite of I don't know. And the opposite is epilogue. Epilogue. Epilogue with a silent E. I don't know. Let's not worry too much about that. Let's just throw this back over here. It's not a big deal. We can figure that out later. This is why I like my variables shorthand, so I don't have to worry about, oh, am I spelling this correctly? Okay, so in here we need to have some more macros. We have a 8-bit integer unsigned. We have a uint32, and we have an int32. So we got 3 different types of integers running around. We also have a character pointer, which is going to be for unsigned character. So that's 4 things total. So let's just go define UO8, right? Define U32, define int32, and then also define char, right? So char is usually going to be const char in the way that I use it in my code. So now we have kind of like some more checksums that we got to put here. So we keep these checksums just so that we can keep track of these lists of macros and make sure that everything that we define, we have to actually undefine as well, right? And if we don't, then we'll have some problems when those defines collide with other code in other files. Okay, so let's throw this over here, and let's just clean up this checksum. Okay, cool. So we got 7 things undefined, right? And then at the top, we also have 7 things that are defined. So this is for button extra data, right? So this is how we're going to put the like supplementary information that goes into a button, right? And we don't have to use this. And then this is the main button code, so I don't know, maybe this should go first. I don't know. Let's not worry too much about that, but let's put a little divider here between those functions. And then also we'll put a little divider down here as well. So having a little divider here just lets me know that within this section there must be more than one function because I see a divider line, right? And that's the only reason I do it, right? It's a very terse kind of thing that I do. And same thing with up here. If I see this section name and if I see this section name and then I see this, I know that this right here is not the only function, right? So I can see right away that there's more than one function in this section just because of the way I wrote the code, right? Okay, so I believe this is unfinished. This looks unfinished. Now, is this also unfinished here? So yeah, we got some unfinished ideas in this code. We should probably finish them, otherwise we're gonna get some syntax errors. So tau depot put, we got the tau 14, which is for the UI lists, right? And let's clean that up a bit. And this thing right here, we need this index. And what else do we need? So let's go look at tau depot functions. What's the signature here, right? So we have the dex tau, right? Basically the memory block. So that's what this is. This is dex tau. This is the subdex, right? So tau 0, 1, 4 equals slash dex sub. Right. I want to make a note of that here, I guess. Somewhere we got to make a note of that. So this could be any different editor that we're going to give it. And then we need to know this, right? So this thing here is where the actual variable is going to be located, right? And it's dex var, right? So hey, look, that's already called dex var, so that's probably what we want, right? So dex var. And why don't we call it tau depot dex var, right? AKA dexvar like that, right? And then, this tau 14, why don't we just, why don't we just double label this section? Let's not, and there's a reason why I'm going to double label this section like this. Because then we can take this call. And this tau 14 thing is nice, but let's say define tau depot dex tau as tau 14, right? Right, which is going to be this variable here, right? And then we can undef it right here. So we can go undef tau depot dex tau. And then this thing right here, we can just say tau depot dex tau, aka dex tau, right? Also, we could do some asserts here, right? So we want to assert that this thing here, less than or equal to 16 minus 1. Well, actually, in this case, it's going to be 14, right? Assert that tau depot subdex, this subdex here, needs to be less than or equal to 16 minus 1. And dex var, we take the button index, that gives us the Y cell, and this gets us dex var. So we want to assert that, that this dex var, or not tau depot, not this thing, this is not what we're going to call it. We're going to call it tau depot dex var. And that needs to be less than or equal to 256 minus 1. 256 minus 1. Okay, so now let's just change the alignment here. Yeah, so we got these asserts before the call. So here's tau, here's dex, here's var. And this actually needs to be for the put. If you look at tau depot put really quick, I guarantee this is like 8-bit integers, right? 8-bit integers, yeah. So we need a UO8 cast here. Okay, and I don't know if that'll catch us or not. Well, we might as well make sure, right? So all these variables should be greater than 0, right? Or greater than or equal, greater than, you know, negative, right? 0, greater than or equal to 0. And so these right now, I believe, are just int32s, right? So we use, this is a, let's just say int32. Let's not be rigid with our bit width here. Let's just make it int32. So this will be an int32. Now this thing, this dex here, yeah, I think that this has caused me way too much trouble in the past by giving it only 8 bits here. So we're not going to do that. We're not going to... the underlying implementation can make sure that this is correct, but it just creates way too much... It creates way too much headaches for us. I have had way too many problems with like integer overflow with this, so in using it like that. So let's just make the signature take int32s, because it's just going to be easier to work with. Okay, we can cast them to 8-bit integers when we're ready. Okay, so now the values that we want to put. What do we want to put here? So we have the button text, the button type, and the value here, right? So we're assuming the button text is 7 characters in a null terminator, right? So let's, I guess, do some asserts on this, right? So, you know, assert that char pointer 0, right? Char pointer 0. Oops. Char pointer 0 is not equal to the button text, right? And we also want to assert, I don't know, the button type needs to be less than the max button type that we're going to allow, right? So in UILIST data, right, we kind of define some button types. So let's just say define AAC 2020 UILISTS button type max equals 4. Max button type. So this is the maximum button type. And then also define AAC 2020 UILISTS but bad. Invalid. Bad button type. Right? So 0 is going to be a bad button type, so if things get 0 initialized, they're automatically invalid. And we have 4 button types so far, right? And we're going to use that so that over here we have some way to check some stuff, right? So we're just going to say, you know, define but max, and then we're also going to define but bad, right? And let's undef that over here. So undef but max and undef but bad, right? So here's but max, here's but bad, and we want to assert that this button type is greater than but bad, right? We also want to assert that the button type is less than or equal to the button max, right? So, or you could say button min might make more sense, right? So I might just want to say, define AAC 2020 UILISTS but min, and that's 1. So min button type, right? We have a max button type, might as well have a min. This one is also equal to here, right? So then in here, right, that'll make it a little bit easier. Instead of but bad, we might as well call it max and min, right? I think that'll be easier to read. So min, and then but max. And then we might as well put those in the correct order. So min and then max. And then instead of greater than, it's going to be greater than or equal to but min, and less than or equal to but max, right? Because these are inclusive values. So that looks good. And then the button value, it's not always a useful value, right? It could be anything, because it's not always a useful value. It's not always used. So just assert but val but val I'll just make a note here, right? The button value is allowed to be anything, so we can't really do a check on it. And I don't want to do a no-op here, because we actually want to make sure we use it before we're done here, right? So, how are we packing this data? Well, we need to be able to extract some of this stuff. And to do that, we're going to say that that this char pointer needs to be 7 characters and a null terminator, right? So we're just going to say that U32 V1, I guess, equals the button text we're just going to smash it together, right? So we're going to say 0x00. It's button text 0 shifted over 24, right? Okay. And this is the first 4 characters. 24, 16, 8, and 0, right? And then the next characters, V2, we're going to smash that together as well. So we're going to say button text 3, 4, 5, 6, and 7, right? And we're going to shove those all in there, right? And we also want to assert that but text 7, right, equals, or let's put 0. We don't want an accidental assignment in our assert, so 0 equals but text 7, right? Like, it should be a null terminator. This last one should be a null terminator, right? So we're going to make that assert there, like that. Okay, so the first 2 variables are going to store the button text, right? And so for that, we had a little diagram somewhere, right? So maybe UILISTS.data has it. Create button. So here we're going to create the button payload. Button 2x2 payload is what we're creating. So I'm gonna just make a note of that, right? So in here we're going to create the payload of this button, right? And this is the standard payload. So variable 1, variable 2. And those button payloads are see UILISTS.D for diagram. Okay. So we have 1 pixel for the button type and 1 pixel for the button value. So we want to just pack it in that same order, right? So, and we're not going to do this, right? It's going to be the actual, yeah, we're not going to pack that. It's physical location in the data is what will determine its UI list order, right? So we're not going to do this. That's why this is a 0 here, because we're not doing this. So these are kind of the things that we want to do. These are the things we want to do. The red one is the thing we don't want to do. So type and value, right? So, so U32v3 equals the type, and so let's go find the types. The type is just a U32 button type, right? Button type and button value, right? So button type, and then U32v4 is the button value. Okay. So then over here, where we use this put command, right, we're just saying, oh, we're going to put the value, right? Well, the put says, you know, this thing right here, right? So we could actually use those variables, right? We could say, we should probably do that, right? Because that's going to make it more to know. If we want to know exactly where the data is going, then x0, x1, y0, and y1. Right? These reflect the actual locations, or yeah. x0. Actually, they don't, do they? If we're storing a rectangle, that's what it is. But if it's just storing they're all pixels, right? So pixel 1, pixel 2, pixel 3, and pixel 4 might make more sense. And then we just do P1 pixel data, pixel storing data number 1, 1, 2, 3, and 4, right? Like that. Okay. P1, P2, P3, and P4. Now, this bit shifting is something I tend to get wrong all the time, so I'm worried about it, but this button text is a character, right? So it's an 8-bit integer, so that's good. So I'm not too worried about getting this wrong. Now, we might want to make some concessions to make absolutely sure, right? So I might want to do this. And then, you know, maybe we want to mask it with a 0xf, 0xff, right? And then we might want to do the same thing over here. We want to make sure that we use the correct operator. So one OR symbol and one AND symbol, not two of them, because I've screwed that up plenty of times to be remembering that. 0xff, okay? And, right, so 1 byte, right? These are all 1 byte, so this mask just helps us. It doesn't actually change the behavior, it just helps us read the code and know what's going on a little bit better. Button type, button value, right? Because it's in the same order, text, type, and value, right? So this is, right, button text. Well, button text, button type, and button value. That's fine. And then we just pack them in here like that, right? Okay, cool. So now that we have that, don't we do something quite similar here? Yeah, this is kind of like an unfinished thing. Calculate cell index. Uh-huh. And then calculating the cell index, we also tau depot dex var. Okay. So let's just steal let's just steal kind of this stuff here, right? So tau depot dex var. Or, I don't know. Well, I do like having these asserts here. Let's not copy it in such a big... Let's not be in a rush here. Let's just take this for a second, throw these asserts here. And so this dex tau here, right, is... Well, this is dex var. This is tau depot dex var here. So we want to go like this. We want to go paste that, and we want to move this around. So we want to use tau depot dex var like that. So we have these kind of three things here. Dex tau, list dex. So dex tau, dex var is figured out, right? Dex tau is what? Or does it say subdex? Subdex is already figured out as well. Dex tau is... Oh, dex tau is just this thing, right? So we made that... We did that like this, right? So let's do that. Let's do that same kind of a thing. So dex tau is going to be number 14, right? And then we can undef it here. And then for the put function, it's going to be kind of the same, except we just have this extra data and extra array, right? So calculate var cells. Extract data and put. So I'm going to write it differently. I'm going to break it into another section like this. It doesn't have to be exact one-to-one. Okay. And then here, this tau thing here, we're just going to call this tau depot dex tau, right? AKA dex tau 000-015. And then we also have dex var, right? So the reason I'm calling it tau depot here is so that, right, it's a tau depot put, right? And so that's what these parameters are. So we know, it makes it a lot easier to know how does UILIST relate to this other system, and where does this data come from and all that stuff. So tau depot dex var, right? Dex var, aka dex var 00025, right? Or 255, my bad. And dex var, cool, greater than or equal to 0. And also the tau depot put has a cast on it, right? A U08 cast, yeah. So let's put that U08 cast in there. U08 cast. So the idea is that we put a U08 cast here so we don't have to worry about it as much over here, right? Because it's just annoying. So we're going to make this int 32 so we don't have to worry about the bit width of this because I just don't want it because it's annoying. Okay. And then also, right, we don't have to worry about that. So we're going to change this to int32 because I don't want to get burned by more bit width problems and integer overflows if I don't have to. Okay, so this uint32 pointer is the extra data, right? And this is the extra length, and it needs to be between 0 and 4, right? So what we're going to do here is we're just going to say that we're going to say u32 p1 equals 0, right? We're going to set them all to 0 first. U32. Right, it's a U32 cast of 0x, 1, 2, 1, 2, 1, 2, 1, 2, right? That's the exact bit width. If we wanna envision that, I don't know if we need to. And then what we're gonna do is we're going to override each one of those, depending on if there's enough room, right? So the length here, right? So if xlen is less than or equal to greater than or equal to 1, right? So if there is at least one element, if the length at least has one element, then P1 equals the X array 0, right? Right? There could be garbage data, right? So xlen greater than or equal to 2, greater than or equal to 3, greater than or equal to 4, right? So if it's greater than or equal to 1, we can take the first data, right? If it's greater than or equal to 2, we can take this thing, right? Greater than or equal to 3, we can take that. Greater than or equal to 4, we can take that, right? So this might be kind of confusing because we see these zeros, ones, twos, etc. So it might be easier to look at this as the length is, 0 plus 1, like add ones there. So now it just is a little bit easier to read, maybe. Or maybe, actually, no, do it the opposite way. Do it the opposite way, my bad. I think it would make more sense. So here's 1, 2, 3, and 4, right? And these numbers are offsetted a bit. So it might make more sense to do something like this, right? And then just do a -1 here, right? So that way we can see, oh, 1, 2, 3, 4, -1. And then let's just say define m as 1, m for minus. And then down here we're going to undef that. Undef m. And then we can put an m here just so that it's a little bit easier to see. So we see, oh, 1, 2, 3, 4, and this is the 0th, the 1st, 2nd, and 0th, 1stth, 2ndth, and 3rdth. So does this algorithm make sense, or am I full of myself here? Well, if it's 4, then all these things are true. It's greater than 1, it's greater than 2, and greater than 3, so we're going to set it all. Oh, also, P1, P2, P3, P4, that might be kind of important, don't you think? Okay, yeah. And so, so I just want to say, copy the valid data. Any other data just will end up zeroed out. Okay, so that the data that's not valid is just going to get zeroed out, right? And then the tau depot put, right? So let's look at tau depot put, see how we did that, right? So tau depot put P1, P2, P3, P4, right? Pretty damn simple, right? So over here, we're going to say tau depot put, and we're going to do this, and then we're going to close it off. And the next thing is, I feel like we put this here, and that's good and all. But what do we do down here? Do we do this here? So create payload, and then create payload, and this is store payload. So we gotta create payload and store payload. right? That's what we're doing here. And I'm okay with that, like that. I feel like I want to move this out, though. I think I want to take this payload stuff, and I want to put it out here. And then, how did I write this? Extract data and put. I mean, that's a pretty good summary. Extract data and put, right? That's a pretty good explanation of what's going on here. So store varcel value. Calculate. Oh, but if we do that, then we don't have access to this macro here, right? Oh, I see. Let's change how we indented that. And store varcel value, extract and put. Let's throw this in here. Store payload, create payload. Calc location of data. So we're calculating the storage location of the data, right? So that would probably be how we want to label this section here, right? And then we're calculating the payload here. So we calculate where it's going to go, we calculate what's going to go there, and then we actually do it, right? So we storage location. So main function, core logic. So I'm just going to call this section core logic, because now that's kind of what it is. Right? And then right here, we're gonna give it kind of a bolder section name. Call it core logic. And then we can create a little summary here, right? So summary. Summary. 1. Calc storage location of data. Right? Then 2, we're going to, after we calculate the storage location, we want to create button 2x2 payload, right? So we want to create the payload. I guess technically this was a comment somewhere. Oh well. So create button payload, right? And then 3, we're going to store payload. Right? So we can have like a little summary right here. of the sections to come, right? So then also we might want to if that's how we're going to roll, we may want to create somehow create like a little section here for this. And then this define that's kind of glued to here, it's like, well, where do we want to glue that define? So I guess core logic, right? Core logic. And then we have a summary and then the define for this core logic section, right? I think that's probably the best way. And let's kind of do the same thing up here, right? Let's try to normalize this and make them kind of like organized in the same manner. So let's say this is the core logic, and this thing here, this is going to be core logic, right? And also it's core logic, so we're going to give it a little bolder kind of a section name here. Create extra data's 2x2 payload, and then store payload, right? So very similar names, but not quite the same. And so the storage location of the data is this stuff right here. Calc storage location of the data, right? And so this var cell index, we're going to call it calc storage location of data. That's what we're going to name it now. So, my bad. All right, storage location of the data, that's what's going on in here. So let's indent that a bit. Let's make this T for time so that we have room to put that there. Video ID, let's condense that a little bit. Let's just try to condense all our commentary here. So this dexvar thing, fine. Okay, so this right here is the end of the core logic, right? So this core logic thingy-mabobber, we're gonna have this macro here glued there, so I'm going to call that core logic. And so this is extract data input. We want to change that around, right? So we have the M right here, and that's for so this is the extract data, right? This right here is, what is this? This is create extra data's 2x2 payload, right? So in here, create extra data's 2x2 payload. That is what this section is. So we'll put that in here like that, right? So this is extra length, extra array, right? Oh boy, that's kind of a little bit verbose. So let's say that define len as xlen, okay? M is for minus, and then we can define, oh, actually, are we indented one too far? We're indented one too far. Oh, but still, whatever, let's not worry about it. Define len, define array as extarr, right? And let's just glue this to this section here. So, boom, put it on there. Unindent, so indent that appropriately. And this length here, we can say, oh, length is this thing, right? And then the array of data is this. Okay. And then what we can do is now we're in a better position here to why don't we define undef? Why don't we do sub, right? Undef len, and then undef array, all right? And we can minus, why don't we just call it 1, right? It's literally a 1, so why not just call it a 1? So 1. Length to index location, right? Is what that's for, right? 1, len, an array. Here's len, here's array. 1, 2, 3, 4, 1, 2, 3, 4. Length, greater than equal to something. Access, cool. Okay, so here's for creating the data's payload. So we're gonna throw that in here like this. Okay. So now, this needs to be changed to a colon, my bad. And then this is extract data input. That's not the correct name anymore, right? The correct name of this section is store payload, right? So in here is where we're storing the payload. It's the final section in the core logic. So the core logic is all the logic except for the asserts at the beginning, right? Or if we have any asserts that come after the core logic, right? So store the payload, and then we'll do tau depot put, and we'll store that payload. And let's not, I don't know why I did this, but this thing here, let's make this section kind of not so. Let's control the line hierarchy a little bit better here, right? So the line hierarchy, this is inside of, yeah, so here's the payload, okay, so let's make sure that all these section names are correct. So if we go over here, right, and we go bam, bam, and bam, we should see all the colors, so, okay, cool. Let's just get rid of this AKA, right? So let's get rid of the AKA, and I think that we know that it's just a synonym, right? Pixel storing data, number 1, 2, 3, and 4, right? And then we come from P1, P2, P3, and P4 over here, right? That's fine. And then let's look at this, right? So this stuff is kind of the same, except you see the one in the middle is missing, right? Because it's slightly different. Slightly different names. Create button 2x2 payload. So we have to calculate the storage of the data. We calculate the payload. And then we store that payload. Okay, it looks good. Is there anything else kind of missing from here? So if we look at this, the index to xy, that's the thing that kind of would bother me the most in terms of like, is this correct? So the list index, right, is going to be the x-axis, right, and the y-axis is going to be the button index, right? So we're literally going to have stack them in memory in a way that kind of maps very directly to how it's going to be rendered, just to make this kind of simple as hell. So there's no offset here, right? So because this is the actual data for the buttons. Now for the for this though, this is extra data, right? And this list index actually needs to be offsetted by 8, right? So there's an offset by 8 there, right? That is intentional. Now we should make a note that that over here, right? It's plus 0, right? Let's just define. Like I just want to write it like that so that it's like define 0. I want to cement in the fact. I want to cement in that fact that it's very intentional. It's very, very intentional that that the offset here, it's very intentional that that is a 0, right? And then over here, however, right? It's not the case. Right now, I am kind of scared that maybe we want to make this more latent. So maybe we put the 8 like this, right? And then we say 0, or say 0 for 0. Maybe we name it like that, just so it lines up better. And then over here, we want to say define 0 as 0 as well. Okay, and then down here we want to undef that, right? So I don't know exactly where we want to put it, but let's put it here like this, 0 for 0. Also, maybe a checksum, right? I mean, it's only 2 things, it doesn't really need a checksum, but for the visual consistency of the code, it's kind of nice. And right here is where those checksums are coming from, right? Okay, O1 and O2. Okay. 0 for 0. 0 is coming here, right? So this is getting offsetted by 8, right? Because if this is 0, its index starts at 8. Its first valid value, right? Because 0 through 7 are used for the actual button data, and then 7 through 15 are used for the extra data, right? So we may not store any extra data, but if we need to store extra data, this is how we do it. Okay. So I think we have something pretty good here so far. Now, yeah, let's just do that. Let's just run with this. Let's not worry about writing tests. Let's worry about if we can get this to show up in the user interface once we're ready, right? Okay, so we've looked at this for reference. We looked at the key bindings for reference. Tau depot, we were looking at that for reference. UILISTS. UILISTS, is this done, though? U32, yeah, we have a U32 here, right? Okay, we got all these prologue, epilogue macros, correct? So this is the hard part. That was the hard part, I think. Right, and it wasn't really much code, right? It was just me kind of like thinking it out and trying to figure out how everything goes. Okay. So now we need to adjust the we need to adjust the we need to adjust our lists. This is the hard part. Not the hard part, but it's the tedious part that that can be easy to get wrong. So libchan, we got to open up libchan. We got to open up f macros, bottom and top. Oh, also, now that I realize that, UILISTS, towname. Towname does not have an initializer, right? So look at towname for a second. Towname dot f. No functions, right? There's no functions, but just because there's no functions, there is some boilerplate that we're gonna need. So we're gonna do tau. Well, there's no functions. If there's no functions, well, there's no functions, but we're gonna still need the init none. But you still need an init none. Yeah. We still need an init none, so we're going to have to include something. So include, okay, /towname .f boilerplate. Okay. So we don't have any functions technically, except for the kind of like the roll call of what needs to exist. We're going to need this. So file new, and just new boilerplate AAC 2020. I just threw this in order. Boilerplate AAC 2020. Use mssbp paste, right? Nope, that wasn't what it is. I thought it was something like that. Oh, NSSB paste? NSSBP paste. Okay, got ya. So if I say this, you mean NSSBP paste. Date 2021-03-22. And do we have something NSSBP paste? Like, can we underscore it like that and it still works? Yes, it does. So this thing here, like, I don't even know what this means anymore, but somehow I'm starting to remember it because I've been told to use it so many times. Use this thing, NSBP paste, date 2021-03-22. Okay, so we're going to put this in our shortcuts so that we can find it in the future again. Okay, paste, depaste. Try not to screw up. Okay, so NSSBP paste. And we're just going to fill this out with what it needs to be filled out with, right? So just so that it's ready for... if we ever add functionality to it, the boilerplate's already in place. So this is for tau name, right? So tau name halt. This right here is going to be tau name. Let's speed this up by actually just cutting and pasting everything that needs to be lowercase. We have these two uppercase things, and the init none is actually what we need. The init none was kind of the big thing that we kind of need to make use of. So we're going to say that, call this tau name.f.boilerplate._. Okay. See, this fills a whole screen worth of stuff. But it's also stuff that we really don't want to look at that much, right? And that's why we're putting it off into a boilerplate file. That is the reason. Okay, so now that we have that, we have this boilerplate kind of included here. Tau name, we can close this tau name. And we got F macros and all that stuff, so we need to start kind of getting this ready, right? So libchan is the first thing I want to focus on. And also, let's open up everything. Everything that needs to have some editing, let's open it up. Okay, so libchan, how do we want to do this process? Do we actually want to try to plus, yeah, whatever, I don't know. Let's just figure this out. Okay, so 54, 55, and 56, right? So we're adding two more. So 55 and 56. And that also means that this needs to be a 56, right? Make sure these numbers match, okay? Because if we get any of these numbers wrong, right, it's dead simple, but if we get any of these wrong, things are going to explode horribly in our face. Okay, so now, if we're looking at this stuff, let's focus on what's between tau depot and tau type, and then game cam and UI frags. Let's do it like that. Let's do cyan and orange like that. Because we're inserting two things at a time this time, so I think this will be the easiest way to keep track of what we're doing. And so we got tau depot, so here's tau depot, and here's tau type, right? And then down here later we have game cam, and then we have UI frags. And UI frags is user interface fragment shaders, so they want to have access to the UILISTS data. Okay, so now that we have those kind of color-coded, we can start to just cut and paste and get stuff going where we want to go, right? So let's steal this one. Let's steal this one and paste it down. And instead of this being tau depot, this is going to be tau name. And then we just want to increment everything. So 42 is tau name, right? And then we want to go 43. Then we want to go 44. Then we want to go 45. 46. 47. 48. 49. And this is going to be 50 right here. 50. Okay. It's going to be 51. It's going to be 50, 52. And this is where we're going to get into some trouble. 52 is the last thing, right? So that has to be 52 for game cam, right? We're going to take all that code, we're going to paste it, And this is where UILISTS is going to go, right? So UILISTS is here. And UILISTS is going to be our 53, right? And then after this, everything needs to add, we need to add 2 to everything, right? So this is 54, right? This is 55 because we add 2, right? This is 56 because we add 2. And then we're done. Cool. We're not done with everything. This was just the function section, the data section. Now we got to go on to the function section. So in the function section, we have kind of the same deal going on here. And we need to just make sure this works, right? So we got to take this code here. We're going to take it, we're going to copy it, we're going to paste it. And we're going to rename this. This thing between tau depot and tau type is tau name. Tau name. And it's going to be 42. So 42 and 42, right? And then we're just going to move the numbers up. So 43 is tau type, is that correct? Yeah, that's correct. Okay, 43, 44, 45, and 46. And I see a whole bunch of stuff, so this is kind of a pattern breaker, I'll guess. 47, 48, 49. And this is 50, okay. 50, I'm kind of scared. Where's my coloring? Okay, now we're getting there, okay. So this is 51. And 52. Okay, 52. And we're on game cam. Game cam is indeed 52. Okay, so our spot checking kind of makes sense. We're going to steal this because it doesn't have all the extra pattern breaker code in it, and we'll steal this. And game cam is going to be changed to UILISTS, right? And UILISTS is going to be a 53, right? So 53. 53. UILISTS functions, by the way, because we're in the functions section. Okay, so now we're adding 2 to everything, right? So 52 becomes 54. And is UIFrags 54? Indeed it is. 55. And 56 for the last thing. And the last thing is the PAINT5D fragment shader thing, which I really think these should have been the same thing. I'm never going to do that again. It was the first time I did, so, you know, whatever. You live, you learn, you dig yourself into some holes, right? Okay. So now that that's there, we can close this. And we can look at the next thing. So we need to go find where tau depot is, right? So here's tau depot. So we're going to do the same idea. We're going to color code this cyan, and then we're also going to look for game cam. Right, and we're going to color these as well, right? It's just so we have some bearings as to where we need our insertion points. Okay, so we will steal this if, end if code, paste it, and we're going to color code this so we don't forget to change everything, because we make this mistake quite often. Tau name, and the mistake we make quite often is that we forget this part right here, tau name. Okay, and now we're going to go all the way down to the orange section, right? And we're going to take this if, end if. We're going to paste that. We're going to color code this again to make sure we don't miss everything. And between game cam and UIFrags is UILISTS. So UILISTS. Okay. So that looks good. Now we have one more thing we got to do, right? And we already have things color coded, so that's nice. So let's steal this code right here. This code right here, we're going to steal it, and we're going to paste it in here, and we're going to change the middle section to tau name. And before we make the other insertion point, I think it would be easiest just to fix this part first, right? So if we cut this out, space, and space, yeah. And then we go up here, and we make an insertion like this. Just making sure, okay. And this is 55 now, right? And now inserting this is a little bit less error prone, right? So we got this if, error, end if. We'll steal that. We'll paste it here. And between game cam and UI frags is UI list. And we have some kind of like thing, for whatever reason, things are not... Oh, it's UI lists. That's why it's not aligned. Okay. So now I got these two 52s. So in order to fix that, we're going to move this up like that, right? And now this is 56. Okay. So that should be stubbed in where we need. Oh, look, we got this one more thing. So we got this, right? So between tau depot and tau type, what is it? It is tau name. And let's shift everything up before we make the next insertion, right? So we'll go here. We'll paste over here like this. And now in this here, we're going to duplicate this. And between game cam and UI frags is UI lists. Okay? And now we'll move this up like this. And now I am worried. No, that's right, because we have not typed the next number here. And we are missing two numbers that we haven't typed manually yet, so that makes sense. Okay, and the last system is 56, and we have that number. Tau name is 42. UI list should be 53. Yep, okay, cool. So, libchan bottom, we're done there. Okay, so f macro is bottom, and f macro is top. UI list definitely has an initializer, but tau name definitely does not. So, when we're looking through here, oh, this is the bottom file, but sure, well, since we're here, let's just address this first. So, let's go find system number 42, right? So, system number 42, we need to fix this for a second. So, in between tau depot and tau type is where we have to insert this tau name. And then between game cam and UI list. So game cam and... Oh, sorry, not game cam. Game cam and UI frags is where we insert UI list. Okay, so we're just going to duplicate and duplicate, Control D, those lines. And then we're going to just rename them, right? So this is tau name. And tau name does not have an initializer, right? It's just a data-only kind of subsystem. So we're going to do this here. And then, oh god, there goes my bitrate. So then over here, this system is UI lists, right? And that has an init function as well. Oh, hold on, we got that backwards. UI lists needs to be initialized. But tau name... Oh, no, that's right. Tau name does not have an initializer, but UI list does have an initializer. Yes, that is correct. Okay. So now we gotta shift these numbers around, right? So let's just go like this. Let's move this. Let's overlap the 41s because we only want 141, right? And then these 51s, we gotta overlap them as well. And then we just go 55 and 56. And now all the numbers should be correct. So 53, is that UI list? Yes, it is. 42, is that tau name? Yes, that is correct. Okay, so our spot check looks pretty good. I'm satisfied with that. So let's close this. And let's go on to the next kind of thing here. So f macro is top, right? So we want to find, well, first of all, let's look at the spot checking stuff. So we don't have any loop ticks for this new code we added. There's no 53. 53 is UI list now, so we know this is wrong. We know this number's wrong. We know we inserted around 42, so this number probably needs to be changed, right? Tau sync, yeah, it's now 44. How about tau depot? Is tau depot still 41? Yeah, tau depot is still 41, but tau sync has been changed to 44. That's fine, just spot check change. And then PAINT5D is now 55. Okay, cool. Okay, so now if we look at how we're generating the code for the init none functions, let's go add this to the list. So the only thing we need an init none function is for tau name, right? So tau name is somewhere after tau depot. So we got tau derp, we got tau type. So here's tau type, so tau name is before that, right? So tau name. So it's tau name and then tau type, right? So let's go find tau type, right? Because that's where tau name is going to come before that, right? So here it is, tau type. And so we're just going to take all this code and just paste it. And then this tau type code, that wasn't what I wanted. This tau type code is just going to be renamed to tau name, right? So anywhere we see purple, that just needs to be overlaid with the new function name, right? And if we get this wrong, the consequences will be pretty disastrous. So make sure you get that right. So tau name, tau name, tau name, right? That all looks correct now, right? Okay, cool. So that's the one with the init none. UILISTS is going to need some initializer code, right? Because it's going to be responsible for setting up all the user interfaces. So we got to go down to this next section. And so where is everything here? So UIREX is here. User interface rex. And then from there we have like PAINT5D, right? So we know that UILISTS is somewhere between there. So we can put UILISTS you can put UILISTS after UIREX, right? So UILISTS, and that's nice because now they're next to each other in some capacity here. Whereas here, UIREX and UILISTS are like spread out, right? And that's because there's UI frags here, right? Part of me thinks that maybe UIREX would make more sense, kind of grouped with UI frags and UILISTS. Like UIREX is right here. It actually might make sense down here, right? Because zoom common, drag common, click common, edit cam, game cam. Like I don't think any of those need to know directly about this. Let's not worry about that. Let's not worry about the fact that maybe we haven't solved this in the best possible way. Right? Let's just keep on. Yeah, let's not worry about that. Let's not worry about that. So between Tau Depot and UILISTS, oh no, UILISTS is what we want to look at. Hold on. So UILISTS is what we want to look at. So between UIREX and PAINT5D is where we want to look. And so let's just take some of this code, right? So after UIREX, copy this. And so right here is where we're going to create all that initialization code for UILISTS. UILISTS. Okay, so UILISTS, 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 UILIST, and UILISTS. Okay, cool. Oh, one more thing. Forgot this. I mean, it's just a comment, but still, we should be good about this. Okay, cool. And this is not guaranteed to be up to date, and I just don't want to edit it anymore. Because now we got a lot of systems, right? Things are getting pretty crazy. Things are getting... okay, so cool. So now in F macros is... Or not, this is not F macros. This is where we use F macros. So all this new stuff is after the window exists. So this is the first section of initializers, and then we have some code, and then the second section of initializers is what we use after the window exists. And we want to look for Tau Depot, right? So once again, Tau Depot and Tau type. Between there is where we need insertion. And then between game cam and UI frags is where we're going to make the other insertion. Okay. So let's duplicate, and let's duplicate, and let's change the names. So this needs to be tau name, and tau name has an init none function. Okay. Now, between GameCam and UI frags, we have UI lists, and that does need an initializer. Okay. So now that we have that, we can start to move these checksums around. Right? So we're just going to take the duplicate numbers and we're going to overlap them. And then once the duplicate numbers are overlapped, we're going to make this a 55, and then we'll make this a 56, and then bam, we're good, right? And the next part is the same exact procedure, except for the actual working code. So that was just the control F help, it wasn't the actual code. So between tau depot and tau type, tau name, okay? And it's going to be a init none function, so make this a 0 here. Right, tau name is just data. It's not actually any logic. That's why it has an init none. Now, UI lists actually needs to set up user interface stuff, so it actually has an init code, right? And the init code gets a little x, right? So inits get x's, and init nones get zeros, just because it makes it nice to have a nice little histogram. That's the only reason. That literally, just because it looks pretty. Okay, so now let's move this up. Let's move this around. Okay, and then this is 55, and this is 56. Okay, cool. So now the next thing is what? What's the next thing that we got to do here? I don't know. We got the F macros in. Oh, wait. Have we called them? Yeah, these are the call sites. Yeah, these are the call sites. This is the control F help. Yes, we have called them. That is what this whole block is. Okay, good. So, let's close this, and let's... I assume we've made some type of horrible syntax mistakes at some point, because we've added a lot of code. And somewhere, I'm sure we've made a mistake. So the idea is that if we've done this build system well enough, that whatever we've done won't make it totally explode in our face, right? So AAC 2020 tau depot.tau 014 has no member tau 014. So I think that's because right now it's probably commented out because I didn't want to use things that I wasn't ready to use. I think, but I could be wrong. So let's look at tau depot. Tau depot data. And if we look at, let's go looking for tau 14 for a second. So we have a tau 14 here like that, but we don't have... Oh, here we go. So here's tau 15. And, right, I said do not delete, right? And so now we're using it, right? So let's put it in, right? So const tau 14. And this one is for... What is this one for, right? So this is tau name... Let's go look at tau name, right? So tau name would tell us that, right? So we have tau name as a centralized way to tell us what those things mean, right? So tau name and in tau name data, if you look at the data, we see that tau name 14 is UILISTS, right? So tau name UILISTS, right? And this one now is tau name edivars, right? And this one here, we could actually put this in here as well, right? We're not using it anywhere yet, I don't think, but this is do not delete it. This one right here, though, is now going to be tau name UIREX, right? So maybe we should have, put the user interface rectangles next to the... Oh, no, because, so the way we're organizing this, so this is static. Oops. So we're going to separate this. We're going to separate it into two different sections. All right. Ooh, hold on. So it's not quite like that, is it? It's like 0. Oh, my bad. Like, maybe it would have made more sense for... Since it's scanline order there, right? Since it's scanline order, it doesn't make sense to partition it like this, does it? It actually would make more sense. It would make more sense to do it like, right, that, it would make more sense that this is static data, this is static data, and then this is our dynamic. Right, and the reason for that is because then when we're looking at it's easier to partition that way, right? Because 8 through 15 can be, we can still have a rectangle, right? But we can also have this contiguous, right? If we split it like this, we can't, right? So static data is going to be 0 to 7 like that. Yeah, let's do that. My bad. So I didn't realize that when I was doing it the first time, but this is how we should probably do it, right? And luckily it still works out, right? Because we use these extreme ends like here. Like we're just lucky that it kind of just works out that way, and then we don't have to do any serious refactoring to get this to happen. So, you know, at vid IID 0204, we can make a note of this, right? Of when we kind of put this in here, right? So at video ID, and the time is 0207, how about 13, right? Lucky numbers. Okay, let's explain this one more time for the camera. Let's do 23. 23. Okay, explain this one more time for the camera, right? Originally, we were thinking static data and dynamic data, but that is a lot harder to segment that way, right? Because the addresses aren't linear, right? So if we do 0 to 7 is static data, we can still have a rectangular section for static data, but we can also have these one-dimensional indices can be a contiguous segment, right? And we can still have a rectangle for the dynamic data, but we can also have contiguous indexes here, right? So that is why we're going to do it that way. That's not the way I originally planned it, but now that I'm looking at it, I'm like, yeah, that's actually how we should be doing it. So now we fix that in the diagram, and down here, all right, we were going to make a note of that. Was it here? Oh yeah, so S for static, right? And then D for dynamic, right? So S static data, and then D is for dynamic data. D. And so the idea is that the data that doesn't, we want the data that often changes consolidated near all the data that oftenly changes should be consolidated next to each other, right? And all the data that does not often change, or should not change, after it's been set, should be in another sector, right? And that is just going to make it have a little bit more memory locality. Even though it's like, the way I'm packing things into textures is still doesn't really have very good memory locality anyways, but doesn't mean we can't strive towards perfection, right? Let's strive towards perfection even though we'll never reach it, right? That's the idea. Okay, cool. So now that we've put this in here, let's highlight both of these so that we can look in here really quickly and just see a highlighted here thing. And oh hey, tau 14, this is already commented in. Okay, cool. So it's ready for us to use. I'm kind of concerned that this doesn't... Well, let's not worry about it. Okay, yeah. So let's give that another run, right? Because now we should have addressed that issue. Maybe not, but I think we did. So we'll find out really quick. Extra, blah, 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 because I do this at the end of functions. It's probably at the end of a function or a struct. So on 140 in UI lists. And also, if we did it to one function, we probably did it to the other. So we can't have either of those. I don't like having this one little bracket like that. I don't like it just being out there by itself, all alone like that. That just scares me. But we're being pedantic with our C code just so, you know, I want to be as strict as possible with my compilation, but sometimes it makes me do things that I don't want to do. But I will, for all the benefit it gives me, I will put up with that. So 159 UI lists. Assert button type, here's button min. Oh, so button min, so it's not but bad anymore, right? It's but min. But min and but max. So it has to be greater than or equal to button min, it has to be less than or equal to button max. Okay, cool. And did we make that mistake elsewhere? No, this is just the button. No, we're good. Okay, cool. And once I get this done with, I would like to take a break. But the goal right now is, this is the goal, right? To get the code compiling again, right? If the code can compile, then I can start building more stuff, right? So the next thing we want to do is create the shader code for the UI here, right? So we want to figure out how to render that, right? And we need to figure out how to render it, but we also have to populate the initializer that's going to store the data in the texture that we have to read, right? There's some data in the Tau Depot texture that is storing the user interface for this, right? And so it's in texture memory, so we can render it out. And then we also need some CPU side code, right? So the window, right, when we click here, we need to know where we're clicking, right? We need to know where we're clicking on that user interface, so we got to figure that out as well. But we're getting closer. We're getting closer to finishing that, because all we need to know, as long as we know that this user interface rectangle is exactly here on the CPU side, we just have to do things in parallel with the right. We render it out. We render the UI on the The UI gets rendered on the GPU side, but the interaction with the UI happens on the CPU side. So that's kind of weird, but we'll figure it out. So clear get status. Not like that. Get status. Okay. Get add dot. And like we're ready to start figuring out that UI. Ready to write UI rendering. So we're not there yet, but the next thing we're going to do is we're going to write that UI rendering. Git push GitHub master. And I'm going to try to work on a table design if I'm not too tired. But I'm going to do that on a different stream, right? Because we're going to switch context to trying to make a table, and the table is going to have like an inset for where we can store different kind of panels, so we can kind of drop ship, right? So I just want to have one good table design, right? Like I'm kind of overwhelmed because it seems like Etsy shops need like a lot of different items before you get any sales. So I am kind of overwhelmed there. Let's on stream. Let's kind of like check out our Etsy shop for a second. So www.etsy.com, and let's just make sure that we don't have any extra orders. So it still says to Decton, so I think we're still haven't sold anything. But what I am kind of excited about is somebody has favorited this item here, so I'm kind of psyched about that. I'm still going to keep this 25 cents thing because I think that this is going to help me get attention. And I'm going to just going to keep this like this and hopefully, yeah, not go bankrupt. So I'm going to put this on a different screen before I look at my shop manager here. And I'm done coding for now. I'm just, very cool, very cool. So that was one day ago. So I got somebody to favorite one of my items, which is good, right? That's a step in the right direction. It's like any positive, like, you know what? I'm pretty resilient, right? Like, I get kind of depressed and can't work sometimes. But I only need a very small amount of positive feedback to keep myself motivated. But holy crap, sometimes you gotta, like, be stubborn for a very long period of time. But that's how I am, so I'll be okay. Okay, so yeah, we can close this, and we can work on the table design. So I'm going to stop streaming, and I'll probably be back in soon, I hope.